Did my standard preaching about saving for retirement lecture. Hopefully, it's something that stuck with you a little bit, gave you something to think about. The other part of that lecture is looking at regular savings or spending. And so there's two types. It's called an annuity, is the term that's used for it.
Recording is on.
There's two types of annuity.
The two types of
One is when you're paying in. So you pay in regularly. You end up with some large amount at the end. That large amount at the end is referred to as a future value. Another possibility. Got an echo coming here. Let me adjust some sound settings. There we go. The other possible type of annuity is you start with a large amount. That large amount you start with is referred to as a present value, because it's the amount that you have right now in the present. And then you either take out regular payments if it's like a savings retirement situation, or you make regular payments to pay the balance down. Either way, there's payments that reduce the balance. To get down to zero. So we're going to look at that first possibility here first, that we're making payments in. So we start with zero at the beginning. We make payments in, and of course we draw interest on what we pay in to get to the end. Now this is an exercise in order of operations and using a formula. P is going to stand for payments, or the payment amount. T, just like it was yesterday for simple interest, is time in years. R stands for rate. Remember, the rate is just that decimal form of a percent, or the percent turned into a decimal. And N is the number of periods in a year. So this is the one. N is be a little bit different than anything we've seen before. N would be, for example, if it's monthly, N would be 12. Quarterly, N would be 4. That'd be 4 times a year. Annually, that's just once a year. There could be daily, which would be 365 times a year and whatever. We're going to stick with those 3 options: monthly, quarterly, annually for now. So if we are paying in, and we want to know that large future amount, that large future value, that future value, that large amount in the future, is equal to the amount of that regular payment times, now that is correct, 3 open parentheses, 1 plus the rate divided by N, we close the parentheses, to the power of N times T, Now remember, is the periods, n is the periods in a year, t is the number of years, so that's the total number of periods. Minus 1, close parentheses, divided by, open parentheses, r divided by n, close the parentheses and close them again. Well, this kind of goes back to what we were doing yesterday. Let's say you're going to have $200 a month from your paycheck. Invested in at an account that is going to earn, even if it's just 6%. If you're in your 20s, that's going to be for 40 or 45 years. So let's just go for 40 years. Fill in this equation here, this formula. We are looking for that large future amount. The payment amount P is $200 times 3 parentheses 1 plus R is the rate, that's 6%, so as a decimal that's 0.06, divided by N, this is each month, so N is 12, there's 12 months in a year, to the power of, and I should put this in parentheses, I didn't put them up here, but I should, to the power of N, which is 12, times T, which is 40 years, minus 1, close parentheses, divided by open parentheses, R is 0.06 for our 6%, divided by N, which is 12 times a year again, close and close. So, on the calculator, 200 times 1, 2, 3 open parentheses, 1 plus 0.06 divided by 12, close the parentheses, to the power of. Now, this is something, depending on your calculator, you got to be careful here. I did to the power of, and then in parentheses, I'm going to do 12 times 40 and close parentheses. On this calculator, I don't need to do anything here. Once I close the parentheses, it knows the power is over. If you have a calculator that actually, like some of the newer versions of the TI-30, actually move the cursor up through the power, you have to get the cursor to come back down to the normal level before you keep going. To do that, you would have to hit the right arrow on your keypad to get it out of the exponent there. So, the power of 12 times 40 minus 1, close parentheses, divided by open parentheses, 0.06, divided by 12, then we close the parentheses twice. $398,298.15. Now, there's two things going on there. One is, the biggest thing there is 6% is a pretty low interest rate for retirement savings. $200 a month is actually not a terrible amount to save. Let's go in and change it, and although you could really be saving a lot more than that as you move on, once you get advanced up the pay scale. Let's look at this. What if it is at 10% instead of the 6%? So the future value will still be 200 times 3 parentheses, 1 plus 0.10 instead of 0.06, divided by 12 to the power of, that's still 12 times 40, minus 1, divided by 0.10 again instead of 0.06, divided by 12. So let's do this. 200 times 1, 2, 3, 1 plus 0.1 divided by 12, power of 12 times 40, Now here you see that now it's $1,264,815.92. Considerably larger. You're not putting away any more money, you're just investing it wiser at 10% instead of 6%. I know a lot of people that, they're getting 1.5% on some of their money in the bank right now, and they're saying as well, rather than take a risk, it's safe, it's guaranteed money, I don't have to worry about it. But that difference, especially if you're in your 20s and you have 40 years to go to retirement, you can see the difference in what you're going to potentially gain is really worth it. That's just a few percent from 6% to 10%. So it is a big deal, is what I'm saying. Okay, so let's look going the other direction. Let's say you know how much you want. You want to find the payment if you know the desired future value, that large amount in the future. Well, that's just this formula that we did up here in reverse. Instead of the payment times this whole big factor, find the payment, taking the future value, divided by that whole big factor. 1 plus r divided by n to the power of n times t minus 1, close parentheses, divided by r divided by n. Everything here you'll notice is the same except for its divide here, and then this is the future value and the present value are switch spots there. The future value and the payment, I should say, switch spots. Let's say you want $1 million. To retire. And for many of you, you have 45 years if you're in your early 20s. I know how much should you invest each month? I need to give you a percent, so at 11% return. Now, we discussed yesterday the average return, annual return on an investment that's 40 plus years over the last 140, 150 years of the stock market is actually like 12 to 13%. So 11% is not impossible. Actually, relatively reasonable if you get the right investment planner helping you with your investments. Well, let's figure this one out. We want $1 million. Oops. I showed up my payment is, we want $1 million in future value. It's divide now instead of times. 1 plus our rate of 0.11, and we're still paying in monthly, so we're going to divide by 12. The power of 12 times, it's 45 years now, minus 1. Close, divided by 0.11, divided by 12. Close and close. So put this in. That's 1 million. Divided by, we have 3 open parentheses. 1 plus 0.11 divided by 12. Close parentheses to the power of 12 times 45, close parentheses. Again, this is where in your calculator you might have to use the right arrow to get out of that elevated mode, that superscript mode for your exponent. Minus 1, close, divided by 0.11, divided by 12, close and close. Only need to save $66.90 a month. To me, that's a pretty significant number. I really think if you knew that would make you a millionaire in retirement, coming up to 66. So something to keep in mind. Okay, so now we're going to go totally the other direction. Here, we're going to start with a future value, and we're going to find those regular payments. So this can be done two ways again as well. Either you know the large amount and you calculate what the regular payments are, or you start with a present value, not a future value. PV, present value. You have an amount right now, and you're either drawing out those payments as you retire, or you know how much you want to draw out on a regular basis in retirement, and you need to figure out what that large value is. Now, the exact same formula also applies to figuring out loan payments. So we're going to start our formula here. The regular payment is equal to that present value divided by 3 parentheses, 1 plus r divided by n. Looking similar to the other formula so far, close parentheses, to the power of n times t, minus 1, close parentheses. It looks exactly like the other formula so far. But here's where it starts to get different. N divided by t times parentheses 1 plus n divided by t, the power of nt, close and close. You got some extra stuff at the end here that we didn't have when we were paying in. That's just the extra interest that's going to be accumulated because you're starting with that large value and paying it down rather than starting with nothing and paying it up to a total. So here, let's take an example. Let's take the example from above here. We paid our $66.90 a month in to get $1 million balance in 45 years. Let's say that's at age 67. Let's say you have $1 million. You want to know how much can you draw out each month. Now, we need to know two more things. One, we need to know what interest rate is. When you're drawing out, you tend to invest in a little bit safer fund, so you get a little bit lower interest rate. So let's say at 8%. The reason is if you're 35 years old, in fact, the closer you get to retirement, the lower your interest rate tends to get because you start to invest a little bit safer. Because at 30 years old, if the market crashes and you lose a bunch of money, you have 30 some years to recover from it. And like we said yesterday, usually when there's a big crash, there's a big recovery where there's rapid gains. So you have time to make it up. If you're 60 years old and there's a big crash and you lose a bunch of money, you might not have time to wait for it to go back up to gain back the money you lost. So when you get, hit those 50s and 60s, you usually start to invest a little bit safer to make sure that money is going to be there for you when you retire. And also, once you retire, you want to make sure it's there. You don't want to be in retirement and lose a bunch of money and realize you can't afford to stay retired anymore. But anyway, let's say you're going to get 8%, drawing out monthly. Then we also have to define for how long. Let's say your family history shows that people live to be about 85 years old. So if you're retired at 67, let's say we want to draw it out for 20 years. So our formula here, that regular monthly payment you could draw out from that $1 million divided by, reopen parentheses, 1 plus 0.08 for our 8%, divided by 12 because it is still per month. The power of 12 times 20 because we're only going to draw for 20 years. Minus 1, close parentheses, divided by 0.08 divided by 12 times parentheses 1 plus 0.08 divided by 12, close parentheses, power of 12 times 40, close and close. You can see this formula takes up quite a bit more room. Let's punch that in. Our $1 million divided by 1, 2, 3. 1 plus 0.08 divided by 12, close to the power of 12 times 20, close parentheses. Minus 1, close them again, divided by, open parentheses, 0.08 divided by 12 times, parentheses, 1 plus 0.08 divided by 12, close parentheses, to the power of 12 times 20, close parentheses, and we close them 2 more times. So if you're going to gain 8% and you're going to draw out for 20 years, that $1 million gives you $8,364.40 a month. I'm pretty sure I could live off that. That $1 million was more than enough. What is that? It's only right around $100,000 a year. I could probably make a living on. So anyway, all sarcasm aside, let's go the other direction now. Let's say you know how much you need per month or per whatever period of time, and you want to figure out what that lump sum needs to be to afford your retirement. If you're finding the present value, if you know your payment, just like the other formulas we had for paying in, the formula is exactly the same, only the division will change to multiplication, and the payment and the present value will change places here. This is still 1 plus r divided by n, power of n times t minus 1, divided by r divided by n times 1 plus r divided by n to the power of n times t. So let's say you know that you'll need or you want to be able to draw. That means to collect the payment. Say you just need $5,000 per month. I want to be able to do it for 30 years. And you're going to be able to draw an interest rate. Oh, let's just go with 7%. So to find the amount of money you need to do that, to figure out what that present value has to be, taking that regular payment of $5,000 times 1, 2, 3, 1 plus 7% is 0.07, still monthly, so divide by 12. The power of 12 times 30, because it's 30 years, minus 1. Close parentheses, divided by, again, it's r 0.07, divided by 12 times, parentheses, 1 plus 0.07 divided by 12, close parentheses. The power of 12 times 30 again, and we close up the parentheses. Let's see what this gives us here. 5,000 times 1, 2, 3. 1 plus 0.07 divided by 12, close parentheses. The power of, open parentheses, 12 times 30, close parentheses, minus 1. close divided by open, 0.07 divided by 12 times parentheses, 1 plus 0.07 divided by 12, close the parentheses, to the power of 12 times 30 again, close, and then close them twice. Giving us 750,537.84. We need just over $750,000 in order to make that work. So if you're going to stay retired for 30 years and want to draw $5,000 a month, you need about $750,000 saved up at retirement if you're going to be able to get 7% interest as you draw it out. Okay, so now I promised you this yesterday. Let's look at the cost of a $50,000 truck. Or car, I guess. This is kind of scary when you look at it. And what we're going to do is we're going to look at that $50,000 car. The standard in the industry. Now, I can remember at one time when I said I would never finance a vehicle for more than 5 years, for 60 months. Well, for the last 7 or 8 years, the standard in the industry was, let's stretch it out over 6 years for 72 months. And now with the price of cars, the standard is 7 years, which it just makes me sad. So anyway, so we're going to finance this for 7 years. But here's the kicker. We will talk more later on when we do ratio and proportion about debt to income ratios and credit score and how that affects you. You hear all this talk about credit score. Credit score does not determine whether you get a loan or not. Most people misunderstand that. I mean, if you have a horrible credit score, it might keep you from getting a loan. If you have like a 475 or something like that, they might, the only way you can have that bad of a score is if you've defaulted on loans or missed a lot of payments. So they might not give you the loan then. But as long as you have at least a 600 or 625, which is, your mid-range, lower mid-range credit scores, you're still going to get the loan. The difference is if you have a credit score of 625, you might be paying 7 or 8% on an auto loan. If you have that credit score of 730, 740, you might be paying right now, I'm paying 1.99% on my auto loan. Now this example is actually pretty accurate. I have a friend of mine who bought a car almost identical to mine. Now mine is not $50,000. They are paying 7.2% on their loan. I'm paying 1.99% on my loan. The balance, the amount of money we started with was the same. There's a significant difference in the payment. So let's start here with the 2%. So why do you want a good credit score? Well, if you have 2%, your payment is going to be that $50,000 present value divided by, three parentheses, remember it's the same formula as drawing out the money from your savings and retirement. 1 plus 0.02 divided by 12. The power of 12 times 7, because we're going 7 years, minus 1. Close divided by open 0.02 divided by 12 times 1 plus 0.02 divided by 12. The power of 12 times 7 again, and then close up the parentheses. Punch this all in. Get a payment amount of $638.37. Now that payment amount in itself is pretty harsh. I mean, that's actually more than my house, way more than my house payment. But let's look at what that really costs. The total cost here is your monthly payment, the $638.37, times your number of payments per year times your number of years. So times N and T. So remember here, N is 12, T is 7 years. So 638.37 times 12 months in a year times 7 years gives us $53,623.08. That's not so bad. What does that number mean, and why do I say it's not so bad? Well, remember, the initial amount for the car was only $50,000, which means over that 7 years, you only paid $3,623.08 in interest. That's not bad. Now let's skip ahead and look at what happens if you have poor credit and if you get 8%. Now, I've had a lot of students come to me through the years with their auto loans or other finances and ask me to take a look. I have seen a lot of cars that were at that 9.9%. I've seen a few at 12.9% if you have really bad credit. Some of the car lots that say, as long as you have a paycheck making more than however much a week, you can show us a pay stub, we'll give you the loan. They're charging you that 11.9, 12.9%. Worst one I saw was I had a student who came in with a 19.9% interest on their car loan. Let's just look at how this one changes if it's 8% instead of 2%. So still our $50,000 starting balance or present value. Now it's 1 plus 0.08 divided by 12. The power of it's still 12 times 7 minus 1 divided by, open, 0.08 divided by 12 times 1 plus 0.08 divided by 12. The power of 12 times 7, and close things up. Let's see what this does to our numbers. So 50,000 again divided by 1, 2, 3. 1 plus 0.08 divided by 12. Close that up to the power of 12 times 7 for 7 years again, minus 1. 0.08 divided by 12 times, parentheses 1 plus 0.08 divided by 12. Close the power of 12 times 7 again. And we'll close that up again. Here's a payment of $779.31. That payment is over $140 a month more than what it would have been at 2%. The real significance is when it comes to the total cost. Take that $779.31 times 12 months in a year times 7 years. $55,462.04. Again, remember the initial loan was only $50,000. So now you have paid $15,462.04 in interest. So you went from only paying $3,600 in interest to paying over $15,400 in interest because you had a bad credit score and had to pay higher interest rate. Now, I've swore to myself that I will never pay $50,000 for a car, but at one point I swore to myself I'd never pay over $30,000 for a car, and that's really tough not to do at this point, if you're buying a new car at least. But these numbers are still significant. If you buy a $25,000 car, $25,000 is half of $50,000. It cuts these numbers. All these numbers get cut in half. But it's still a significant difference in interest. Interest paid between a 2% and 8% loan. So those are the things I want you to keep in mind. So I am done being on my soapbox, at least on the investment soapbox for the semester. If you have questions about it, by all means, feel free to ask. I have no problem talking about it more. I'm not going to force it down your throat anymore like I have the last couple of classes.
You said investing. Where should we invest in the first place?
Well, you just go to a professional financial advisor. There's Fidelity, Edward Jones, Allstate, all sorts of them around. There's Legends Group in this area. Just go in the yellow pages and look up financial advisor. And the key term you want to ask them if you don't want to just pick one and go to them. You want to talk to a few of them. And the key term is you ask them if they are considered a fiduciary. A fiduciary means they are working for you and they get paid by you. So that means is they make money if you make money. So if they get a percentage of your gains is how they get paid. Other financial advisors, they get paid based on what they get you to buy. So their company might be pushing a certain product, and they get paid if you buy that product or whatever. So they don't have as much incentive. They still have an incentive to help you make money, because if you don't make money, you're going to go to somebody else next time. But they get paid based on what they sell you rather than what you earn. So the fiduciary gets paid based on how well your investments do. So continue the assignment from yesterday. I don't have the page number in front of me, but it's at 113. So you should have the formulas from the day should give you the information to finish that. Now, just so you are aware,
+9,
which is coming up on Thursday.
Right, so you guys are going to write in 9 to the middle.
These long formulas like this.
What is 20
These
plus
formulas
9?
are the extra credit. In fact, the extra credit that is attached to the test is mostly about these formulas like this. I will require you to be able to do self-interest stuff from yesterday. Also, I forgot to mention yesterday, there is a quiz out there that needs to be done sometime here before. As long as you have it done before Thursday, I'm okay with it. There's a quiz that was posted out there for Monday for you. So get a chance to get that done and get it submitted. So we are finishing up. We have one more lecture tomorrow to finish up Unit 2. Thursday is the Unit 2 test. That is going to be what?
Okay. Is it the
I will be logged in, but the test will be posted on Blackboard as long as you have it done by the end of the day. You don't necessarily have to log into class. Yeah, Sean, you had a question?
Is it the quiz that you did is it the second quiz you told us to download last week?
The quiz that's out there should be on percents. I will double check to make sure it's out there when I get offline here.
Okay.
But it should be out there. It should be on percents.
I know, because there was another one that was on decimals and shit, and yeah. I don't know.
There's a decimals and there's a fraction one out there as well.
Okay, so I'm just getting confused.
Okay.
Sleep deprivation always is a kicker, isn't it?
Yep. Okay, so that's it for today. We've got the last 7 minutes here. If you want to start on homework, I'll be on the network for a while if you have questions. Otherwise, that is
So-
it.